So here we're going to look at the integral of 3x to the fourth plus 1 over x squared minus 1 with respect to x. And again, I would start with, do I happen to be able to tell what this antiderivative would be pretty quickly? And no, I don't. So next would be u substitution. Well, if I set u equal to be the numerator, I'd have a 12x to the third that would need to cancel. I don't see anything that'll cancel it. If I set u equal to be the bottom, I'd have a 2x that would need to cancel. I don't see what would cancel all of my x's. So u substitution doesn't work. But then I see this is a quotient, so there's a good possibility quotient rule is involved. So I'm going to go ahead and worry about partial fractions. But we have an issue here. Partial fractions only works if the degree of the numerator is smaller than the degree of the denominator. And here, my degree of numerator is bigger. So what we have to do in this situation is we need to actually do the division that the fraction bar represents. So we're going to have to do long division. So as a reminder of how long division is done, I am going to want to put the placeholders for the missing terms here. So I've got 3x to the fourth plus 0x cubed plus 0x squared plus 0x plus 1. And long division is done with polynomials the exact same way long division is done with known constants. So I would start with, what would I multiply x squared by to get 3x to the fourth? That would be 3x squared. So I take this 3x squared times the x squared minus 1. And I put the 0 placeholders here so that it's easier for me to line up like terms. And then I'm going to subtract this. So the 3x to the fourth is canceled, 0x cubed isn't needed. Then 0x squared minus negative 3x squared would be a positive 3x squared. And then I bring down the terms I haven't used yet. And I repeat the process. So to get 3x squared, I would multiply x squared by a positive 3. Take that 3 times the x squared minus 1. Subtract this. 3x squared is canceled. I don't need 0x. 1 minus negative 3 is going to be 4. And that's going to be my remainder. But remember, the way we write remainders is by adding it on as then 4 over what I divided by, minus 1. So now what I have here is that this integral is going to be the same as the integral of 3x squared plus 3 plus 4 over x squared minus 1 with respect to x. And so now we actually have two terms that are pretty easy to find antiderivatives for. Antiderivative of 3x squared is x cubed. Antiderivative of 3 is 3x. But I still have this integral of 4 over x squared minus 1 with respect to x. And I'm not going to write my plus c yet for the antiderivatives until I'm done finding all of my antiderivatives here. So for this part here, I again now have an easier fraction to work with. Again, I don't recognize this off the top of my head. U substitution is not going to work because u would be the denominator and there'd be a 2x in that derivative that wouldn't cancel out. But I see it's a quotient. So in terms of quotient rule, I am now able to do partial fractions. So this 4, and if I factor the denominator, I want to break this up. I'll have one fraction, don't know the numerator, over one of the factors, don't know the numerator, over the other factor. I don't want to work with this as fractions. I'd rather work with it as polynomials. So I'm going to multiply by a common denominator, which would give me 4 equals a times x minus 1 plus b times x plus 1. Then what makes my denominator 0? Well, x equals negative 1 or x equals positive 1. Well, if x equals negative 1 and I plug that in for x in the polynomial equation, I would get 4 equals negative 2a. So a is going to be negative 2. If I plug positive 1 in for x in the polynomial equation, I get 4 equals 2b. So b is going to be positive 2. So now for the integral I have left, I still have this x cubed, I still have the 3x, but I now have the integral of negative 2 over x plus 1 plus positive 2 over x minus 1. And I am going to be doing each of these separately, and if you want to, you can pause the video, do all of the u substitutions. But in the interest of time, I'm just going to go ahead and say that I still have this x cubed, I still have this 3x. Then I'm going to have a negative 2 times the natural log of the absolute value of x plus 1 plus positive 2 times the natural log of the absolute value of x minus 1. And now that I've done all of my indefinite integrals, I put in the plus c. And this is our antiderivative.